Hi guys, it's Mr. Ward. This is day 9 of our Unit 4 on matrices, one of our last real new topics of the unit, and it's called Cramer's Rule, and it's a third way of solving a system of equations. We've done Gauss-Jordan elimination, we've done the inverse method, now we're learning what's called Cramer's Rule. A lot of people tend to like it best out of all three. As a little warm-up, I'm going to ask you two. Determine if those 3 points are collinear, and if not, find the area of the triangle. You could pause it now, work that through, setting up a matrix. Here is my solution. The 2, 8, 1, 3, 5, 1, 7, negative 2, 1, 3 by 3. Copying columns 1 and 2, creating the two left, right, downhill diagonals in green. The right, left, red diagonals. 60 minus 55 is 5. What does that tell us? These points are not collinear. Pretty close, but they're not collinear, meaning the area 1/2 the absolute value, so 2.5 square units. All right, that should be in your wheelhouse. That should be comfortable. Now we're going to do something new. And we're going to start with a 2 by 2. What is Cramer's Rule? It says, given a system like this, something x plus something y equals something else, x, y equals a constant f, how we can solve the system is we're going to find 3 determinants. That's what this capital D stands for, is determinant, okay? And we're going to go dx over dm. M stands for main. dy over dm, all right? So we have a main matrix, an x matrix, and a y matrix. And where are they going to come from are the main matrix is simply, let's see, ABCD, ABCD, the coefficients. Not the answer, just the coefficients. What does matrix X do? It keeps the Y's, but it replaces the X's in the X matrix. Remember that. The X's in the X matrix get replaced with the answers. That EF, okay? And then the Y matrix, that would make sense to keep the X's, which in this case are A and C, and put the answers E and F over there. So again, oftentimes, what does it do? Don't worry about those 2 little caveats. We'll get back to those in a minute. Let's put some numbers to work, make a little bit more sense. Here's our system. Before now, what would you do? You would either use Gauss-Jordan elimination on augmented, or you'd use the inverse method. You need to be comfortable with both of those. Let's try a third one. So I'm going to create a main matrix first, which is 4, negative 3, 5, 1. I use capital D to stand for finding its determinant. 4 times 1 minus 5 times negative 3. 4 times 1 is 4, minus negative 15 is plus 15, 4 plus 15 is 19. That has nothing to do with the answers to x or y. It's going to help us find them, though. All right, let's do dx. dx kicks the x's out and keeps the y's, the negative 3, 1. And what does it do? It replaces the x coefficients with the answers. And we're now going to find that determinant. 14 times 1 minus 8 times negative 3. 14 plus 24, 38. And then our last one, dy equals, y kicks out the y's, so we keep the x coefficients, 4 and 5. We replace the y coefficients with our answers, 14 and 8. And we find that determinant, 4 times 8 minus 5 times 14, 32 minus 70, negative 38. And the last step, let's go back to our definition. The solution to x is the x determinant divided by the main. The solution to y is y determinant divided by main. So what's x? dx over dm, 38 over 19, x is 2, What's y? dy over dm. Negative 38 over 19. Y is negative 2. Solution 2, comma, negative 2. You could check it into both equations. Plug in nicely, and they both work. All right, let's do another one. Main matrix, 8, 2, 12, 3. Let's find its determinant. 8 times 3, 24. 12 times 2, 24. 24 minus 24 is 0. Wait a minute. dm goes in the bottom, and if the bottom's 0, what does that mean? Let's go back to those special cases I was talking about. Case 1. If all the matrices have determinants of 0, the main, the x, and the y, the system's called independent. That means it has infinite solutions. If the main, number 2, if the main matrix is 0, we found that for both, okay? But at least one of the other determinants is not 0, then it's inconsistent and no solutions. So what does that mean for our problem at hand? We found the main is 0. It's a special case. Are the other two determinants also 0? We got to test those. So I'm going to go to x. X kicks out the x's, replaces with answers, keeps the y's. 6 minus 6. Looking like that all 3 zeros. Let's try it. dy keeps x's, kicks out, replaces answers. 24 minus 24. All are zeros. What case was that? Sort of like the row of Gauss-Jordan elimination. All zeros, infinite solutions. All zeros, infinite solutions. We'll leave it at that. We will talk about patterns later on, especially with 3x3s. All right. Let's try a big one. Let's use Cramer's rule on a 3x3. What does that mean? We're going to create 4 matrices. A main, and then an x, kick out the x's, replace with answers, a y, kick out the y's, replace with answers, and a z. Keep the x's and the y's, and replace the z's with answers. We got to find 4 determinants. Copy columns 1 and 2 and find blue determinant. Let's see. 1, 1, 3 equals 3. 1, negative 1, 1 equals negative 1. 1, 2, 1 equals 2. 3 plus 2 is 5, minus 1 is 4. Minus 3 times 2 is 6. 1 times negative 1 is negative 1. 1 times 1 is 1. 4 minus 6 equals negative 2. That's what's going to go on all the bottoms. That's your main matrix. Let's find x. Copy column 1. Column 2. 6 times 3 is 18. Negative 1 times 10 is negative 10. 1 times 3 is 3. 18 minus 10 is 8, plus 3 is 11. Minus. Let's find this diagonal right here. 10 times 1 is 10. This diagonal right here. 6 times negative 1 is negative 6. This diagonal right here. 3 times 3 is 9. 19 minus 6 is 13. 11 minus 13 equals negative 2. If you wanted to right now, we could start solving. X equals dx over dm. X equals dx, pardon me, negative 2, dm negative 2. X equals 1, ordered triple. All right, let's move on to y. Copy column 1. I didn't equally space my last one too well. Got a little jammed up on that. So let's see. Equals 3 times 3 times 1 is 9. 6 times negative 1 times 1 is negative 6. 2 times 10 times 1 is 20. 29 minus 6 is 23 minus 6 times 2 is 12 times 3 is 36. 1 times negative 1 times 10 is negative 10. 1 times 3 times 1 is 3. 39 minus 10 is 29. 26 minus 29, 23 minus 29 is negative 6. Again, if you want to go up now, what's y? dy over dm. Negative 6 over negative 2. Y is 3. Let's do z. Copy 1, 2, 1, 1, 1, 1 equals 10, 3, 12. 25 minus 20, 3, 6, 29. 25 minus 29 is negative 4. Z equals dz over dm. Negative 4 over negative 2, which is 2. So our ordered triple is 1, 3, 2. We could check it back into our system if we need to. All right. One more 3 by 3. Looks like we're going to, I got a couple minutes, but we can just set it up. I'll tell you what the determinants are. You can check. Okay. Actually, let's take a look at this one because it is a special case. M 6, 3, 9, 1, negative 2, 1, 8, 4, 12. 6, 1, 8, 3, negative 2, 4. The determinant of that ends up being 0, which means infinite or no solutions. Last time it was infinite. What's x? Keep the y column, 3, negative 2, 4. Keep the z column, 9, 1, 12. Replace the x's with answers, 7, 1, 8. If I might as well show something new, and I think we have just enough time. Pull up my calculator. No, maybe not. Can't seem to get my calculator today, so I'll just go through by hand. That determinant is a negative 28. I can stop right there. I don't need to go any further. Why? Because if I have my main 0 and one of the others is not 0, that means no solutions. All right. Since we got a tiny bit of time left, I was going to take a look at that infinite solution one right here, and we could figure out the pattern. We'll talk about that next class, next video. Great job today, folks, and we'll talk to you again soon.